Hello, good afternoon. I'd like to present to you a hypothesis that could solve the theory of everything and have major implications throughout physics and philosophy as well. So let's get started. This hypothesis proposes a radical reinterpretation of the foundations of physics by combining two key hypotheses: that we cannot observe the present, only the past, due to the nature of time itself, and therefore particles do not exist, only waves. It is argued that these ideas solve long-standing puzzles in quantum mechanics, such as wave-particle duality and measurement problem, while offering a new framework for unifying quantum mechanics and general relativity. By treating time as a barrier to observation, and waves as the fundamental entities of the universe, it presents a deterministic, wave-only model of reality that challenges traditional notions of particles, spacetime, and observation. We superficially explore the theoretical, experimental, and philosophical implications of this hypothesis, proposing new avenues for research and discovery. The quest to understand the nature of reality has driven scientific inquiry for centuries. Quantum mechanics and general relativity, the two pillars of modern physics, have revolutionized our understanding of the universe. However, they remain fundamentally incompatible, and their interpretations often rely on abstract concepts such as wave-particle duality, superposition, and the observer's role in measurement. These challenges have led to ongoing debates about the nature of reality, time, and observation. Here, it is proposed a new hypothesis: our inability to observe the present, only the past, due to the nature of time itself, hinders us from noticing that particles do not exist, only waves. This hypothesis suggests that the apparent particle-like behavior observed in experiments is an artifact of time-delayed observation, while the true nature of reality is entirely wave-like. We explored the implications of this idea for quantum mechanics, relativity, and cosmology, and proposed a unified framework for understanding the universe. This hypothesis consists of two interconnected claims: time as a barrier to observation. We cannot observe the present because observation requires time to process information. As a result, every measurement reflects the past state of a system, not its present state. Wave-only reality. Particles do not exist as discrete entities. Instead, all matter and energy are manifestations of waves. The apparent particle-like behavior observed in experiments arises from our time-delayed observations of wave interactions. This framework challenges the traditional interpretation of quantum mechanics, where particles are seen as fundamental entities that exhibit both wave-like and particle-like behavior. Instead, we argue that waves are the fundamental entities and particles are emergent phenomena resulting from our limited ability to observe the present. Implications for quantum mechanics. Wave-particle duality. The double-slit experiment, often cited as evidence of wave-particle duality, can be reinterpreted in a wave-only framework. The interference pattern observed is a result of wave interactions, while the apparent particle-like detection is a consequence of time-delayed observations. Superposition and entanglement. Superposition arises from the interference of waves, while entanglement reflects correlations between waves. The apparent collapse of the wave function during measurement is not a physical process, but a result of our inability to observe the present. Determinism. The probabilistic nature of quantum mechanics may arise from our time-delayed observations, suggesting that the universe is fundamentally deterministic. Implications for relativity. Space as a wave medium. In a wave-only universe, space can be reinterpreted as a medium through which waves propagate. The curvature of spacetime in general relativity arises from the energy density of waves rather than particle-like masses. Gravity as a wave phenomenon. Gravity may be understood as a wave interaction aligning with quantum field theory or string theory, where gravity is mediated by waves. Implications for cosmology. Wave-based cosmology. The expansion of the universe and the behavior of galaxies can be described in terms of wave dynamics rather than particle-like matter. Dark matter and dark energy. These mysterious components of the universe may be reinterpreted as wave phenomena, offering new insights into their nature. Time delay experiments. Experiments could measure the time delay between quantum events and their observation to test the idea that we cannot observe the present. Wave-based detectors. Traditional particle detectors could be reinterpreted as wave detectors, which results analyzed in terms of wave interactions. Cosmological observations. The cosmic microwave background and galaxy distributions could be reanalyzed to see if they align with a wave-only universe. The hypothesis challenges the traditional interpretation of quantum mechanics and offers a new perspective on the nature of reality. By treating time as a barrier to observation and waves as the fundamental entities of the universe, we resolve long-standing puzzles such as wave-particle duality and the measurement problem. This framework also provides a pathway for unifying quantum mechanics and general relativity, two theories that currently treat time and matter very differently. However, our hypothesis raises new questions. How can we experimentally distinguish between a wave-only universe and traditional particle-based models? What is the nature of time and how does it shape our perception of reality? These questions invite further exploration and collaboration across physics, philosophy, and cosmology. We propose that the universe is fundamentally wave-like and that our inability to observe the present, only the past, hinders us from noticing this truth. This hypothesis offers a unified framework for understanding quantum mechanics, relativity, and cosmology, while challenging traditional notions of particles, spacetime, and observation. By reinterpreting reality through the lenses of time-delayed observation, we open new avenues for exploring the nature of the universe and our place within it. So that's a small. I try to make it concise and not too long. So tell me what you think about it. Thank you so much.